because I have to have two screens on here. First and foremost, 10.4, we have like a front and a back page for notes. Okay, we're gonna probably get maybe through the top of the second page, and we're gonna talk about dummy variables tomorrow. And then second thing is that on the homework, it does say 10.5 at the top. That is actually 10.4. That's a typo. I don't know why it says 10.5. So switch that to 10.4 so you don't get confused, because this is actually the homework for 10.4. You have a couple, like 4 problems for homework, and that is all. Okay? And the majority of those you can get done today. All right? Got it? So I'm going to go over to here, and this is the next thing that we need. So if you're watching this video, you need to log on to, on your Chromebook or wherever you do this at, to the book website that we used to do at the beginning of the year. You'll sign in. Okay? Are you guys all there? All right, sign in. And this is going to go slow because I'm recording using that stupid way. All right, and then you go to your stats book. So like stats, I don't know, mine has a bunch of different options. I go to stats, third period. So you log into there, and then you should get to the place where like it tells you where your assignments and stuff are at, right? Like this page. Yes? Does this look familiar? Okay, you're not going to go to assignments on the left side or anything like that. You are going to go to the button over here that says Stat Crunch. Okay? Stat Crunch. Do you guys all find it? Find Stat Crunch. Jake Boniface, did you find Stat Crunch?
No.
Go, find it. Stat Crunch. And it should take you to a page that looks like this. Do you guys all have a page that looks like that?
Yeah.
Okay, it has 2 different options that you can select. One says data sets from your textbook, and the other one says Stat Crunch website. We want to go to the top one. It's going to pull up full data, like stuff from our textbook.
Which one?
Data, whatever it said.
Data
Sets from your textbook. That top thing, that top link. So right here, data sets from your textbook in StatCrunch. It's going to pull up StatCrunch. Okay, and then it gives you lists of stuff, okay? So do you guys remember when we were talking about the, the chocolate and Nobel laureates? Like we've been doing that, but we've only been doing like 5. Don't click on anything. This has all like 47 like lists of data. Like I'll click into it, you don't click into it. I'll just show you what it looks like, okay? It will pull up all of the data. There are 23. We were only dealing with 5 pieces of data from this data set, but this has all 23 sets of data that they collected, okay? It has country, it has the chocolate consumption, it has the Nobel rate, the population, whatever internet is used for, maybe their internet speed, I have no idea, but it has all of that random data in here, okay? So this StatCrunch has oodles and oodles and oodles of sets of data, okay? The one that you're going to be using for our notes and for your homework is body data, which is the very top one. So click into him. There is a ton of data that they've collected from these people. All body data. Look at all that stuff, okay? This is as a statistician. This is like what you do. You put it all into a big old fat spreadsheet, and then it crunches the numbers for you. Okay, so let's just look at some of this stuff here. They have how many people did they gather data from? Can you even scroll to the bottom? 300. I didn't get all the way that far. Is there 300? 300? Yep, 300. 300 people. Take it all the way to the bottom. 300 people. But then there's like 40 different categories that they collected. So the first thing was age. Okay, so they collected how old they are. The second thing was gender. Okay, we're going to talk about gender and how they've assigned gender here. Okay, notice that they use the values 0 and 1 for gender. That's called a dummy variable. We're going to talk about dummy variables tomorrow. Then they have pulse and systolic and diastolic. That's your blood pressure. So like this person's blood pressure was 100/70, 112/70, that type of thing. HDL and LDL. Do you know what that is? HDL and LDL?
No.
That is cholesterol. Good cholesterol, bad cholesterol. I'm not sure which one is which.
I have high cholesterol.
Yeah, I do too, for some reason. I don't know. Anyway, HDL, LDL, good cholesterol, bad cholesterol, whatever that does for you, okay? White blood cell count, red blood cell count, platelet count, weight, height, waist circumference, I'm guessing is what that is. Then they do arm circumference, like probably around your arm, like right here, this fatty part of your arm. Let's see what else we got. I don't know how to scroll. Oh, I can scroll over. Here we go. Holy crap. And then BMI is the last one. Do you guys know, have you ever calculated your BMI? Like on the website, your height and weight? No?
Yeah.
Okay, whatever. Anyway, a lot of people don't agree with BMI because like it doesn't take into consideration like your muscle mass also. It's just height and weight, right? Whatever. Anyway. All right, so there is that. That's like a ton of data. Okay, we are going to go and click some buttons here, and we're going to have it tell us what it's just going to spit out some stuff for us. Okay, so as a statistician, you will use a software like StatCrunch. If you go into like research and development, you use software like StatCrunch. You put all your stuff into it, and then it will do oodles of things for you. Okay, so here we go. If we go back to the notes, let's talk about the first example that they want us to do. And we need example 1. All right. We got to talk about multiple regression and what multiple regression is. In the past, we've done linear regression, which is like y hat equals, and I'm just going to say mx plus b. Write that at the top of your notes. Mx plus b. Okay. In this, we only have one variable. I guess 2 variables. This is our output variable, and this is our input variable. Okay, so maybe we were doing height as our output variable, and we want to say that height is based off of wingspan, because I had to do wingspan the other day. Okay, height versus wingspan. So I'll put in your wingspan, and it will spit out your height according to this, right? So like maybe that's an equation that we have. Now what we're going to be doing is multiple regression. So we have multiple variables. So instead of having just one thing over here, like one thing for wingspan, we can include like also maybe your like foot length, and that will tell you how tall you are. Or maybe your age will help tell us how tall you are, right? So those type of things, and we'll have multiple variables over here, okay? So like 2, 3, 4 variables that all combined together will spit out how tall you probably are, right? So that's what we're looking at doing today, and we're going to have the computer do it for us. So a multiple regression, if I read this definition, it is still a linear function. It's a linear relationship because we still have one variable as an output, but now we have multiple variables as the input. It's still a linear function, but we have 2 or more predictor variables, so like 2 or more x's involved, okay? And so this is what it looks like. We have y hat. It will still call it y hat, and b naught is just like our plus b at the end. Okay, but then we have like something x1 plus something x2 plus something x3 ... right? As many variables as we have, and it will spit out an equation for us, and then we can use that to find what this guy is. Okay, happy with that? Makes sense? It's just like y equals mx plus b, but like a bunch of x's. Okay. All right, so this is called a multiple regression equation. We're going to do a couple of examples, and then we'll be done. Body data. That's what we just pulled up on our computers. And they are wanting to, it says data sets, body data includes heights, underline that. Waist circumference, there's a second one. Weights from a sample of 153 males. 153 males, okay? They want us to find the multiple regression equation in which the response variable, y, is the weight, and the heights and the waist circumference are our x's. So I'm going to put y hat equals weight. And our x, we have 2 x's, x1, x2. We're going to base those on height and waist circumference. Okay, those are the 2 things that we are comparing. All right? 153 males. We had 300 total. The total was 300. How many females are there? I don't know. We had 147 females. Okay. We want to get rid of the males first? Sure. Let's get rid of the males. Or get rid of the females, I mean. Let's go over to here. So go to your StatCrunch. Everybody do this. Go to your StatCrunch. Go back to that data tab. And what we're going to do is we're going to click on the gender little down arrow. And, no, we're not. Can I do that? Sort table, move column. Nope. Edit. Maybe we should just do the whole thing. Let's just do all of them instead of just the males. We'll wait till we talk about dummy variables and the males and females tomorrow. So let's just do all. I'm going to change the problem. Can we change the problem? Okay, we'll wait and add that tomorrow. So we're going to do all people, not just males and females. Okay, we'll separate the males and females out when we talk about dummy variable tomorrow. So we're going to do all of the data, not just the 153 female or 153 males. We're going to do all of the 300 people. Okay, we're going to spit out an equation for that. Okay, so I'm going to leave this list the way it is. I'm not going to get rid of the females yet. We'll do that tomorrow. And we're going to have it spit out an equation for us. Okay, ready? Go to stat. Hover over the, hover over the data tab. No, it was stat. It was stat. Hover over the stat tab. I can't read. Okay? All right, go all the way down to where it says regression. You see where it says regression? And then what are we going to from there?
Polynomial.
Nope. Multiple linear, right? This is multiple regression. Multiple linear. Click on it. It's going to pull up a big old fat thing that says, what do you want? Right? What do you want it to base off of? Okay, so we want our y variable to be what? What does it say? We want weight. So I'm going to click on weight for the y variable at the top. Okay? Now, x variables. If you just click on height, you can scroll all the way down because we need height as our x variable. If we click on height, and then we also want waist. If I click on waist, like it doesn't save both of them in there, right?
Shift and click.
You have to shift or command and click, however your calculator or computer does it, whatever. So you have to select both of them. So you have to hit shift and select both of them, height and waist. So if you just click one and then click the other, it's not going to work. It will like get rid of the first one, okay? All right, we're gonna, you can change the settings down here to have it like perform hypothesis tests or not. You can have it do a confidence interval for you, which is kind of nice. And it does all those cumbersome calculations for you. We're just gonna leave that. We're gonna let it do its thing. It'll spit out more stuff than we need, but we're just gonna have it compute. So it has all of the stuff that we want it to do, and we're gonna have it spit out an equation, and it comes with this little box that looks here, okay? So our dependent variable was weight. That was our y. Our x's are height and waist. And then it spits out this equation for us. I'm going to highlight him in blue. The very, like the third or fourth line down, it'll spit out all that junk for us. Okay? So I'm going to write that down over here. And this is going to be the equation that it's spitting out for us. Okay? Let's see if I can keep this on the same screen here. All right. So, and I'm not going to call it y hat. I'm going to call it weight, just so that we remember what it is. So weight is equal to negative 123 point, we'll go just one decimal place for right now, 0.6. You see that? Did you get the same numbers as I did?
Yep.
Maybe? Plus 0.6 times the height, okay, plus 1.0, I'll go 1.04 this time, times the waist. All right, so they are saying that if you're trying to predict the weight and you know their height and their waist size, you can plug those in and you can solve for the weight, and that is how you come up with that. Now, they wanted originally just the male data, okay? Do you think our male data formula is going to be exactly the same as this one? Probably not. Is it going to be similar? Probably-ish, right? Okay, so close to that, probably equation, but probably not the same, because maybe like males are built differently than females. So like their waists, like males' waists typically, you know, like aren't as big as female waists because we gain our weight in our bellies, especially for me, right? So like we gain weight in different areas than males do. We're set up differently. So the equation probably is going to be similar, but maybe with some slight differences. We'll do those comparisons tomorrow when we talk about dummy variables, but this is what they've spit out for all 300, right? Okay? Okay, so there is that. Now, we talk about an r squared value, okay? So we have r and r squared. Yesterday we said r squared was the percentage of data that, I'm going to say that follows the equation, roughly. Follows the, yeah, I'll just say the equation, okay? The percentage of r squared tells you the percentage of data that follows the equation. It's like the explained variation, okay? So they have what's called now an adjusted r squared value. Oh, I should I didn't scoot over. You guys can't see that. Tell me that you can't see that. Right there. R squared. Percent of data that follows the equation. Okay? We have to now go off of what's called an adjusted R squared value because we have more than one variable. So we can't just go off of R squared. We have to go off of adjusted R squared. So it is called the adjusted coefficient of determination. Okay? So that's what he is called. Coefficient of determination is R squared. We have to do the adjusted one. Okay? So go back to your spreadsheet or your thing on your computer. Okay? Find on this little blip of all of the information where the R squared and the adjusted R squared is. What?
The bottom.
The bottom, right up there at the bottom. Okay, what is the R squared value? You see him? The R squared value. He's right down here at the bottom.
0.8871.
0.8871. Okay.
Yup.
0 point. Is that a good R?
Yes.
Yeah, I think so. 88% of our data? That's not bad, especially if we have 300 data points. So we did pretty darn good. And then this is the adjusted, okay? Now the adjusted R squared should be very, very, very similar to the regular R squared. It's just that it's taking into consideration the number of variables that we have. So 0.8863, do you see where it says that? Right below. R squared adjusted, 0.8863. So very, very similar. It's still 88%. Or almost 89%, but it is adjusted for the number of variables that we have. Got it? Okay?
Got it.
Yes? Good? That's how you do that part of it, okay? So basically we're just plugging stuff in, telling the calculator to do it. This is how stats works in the real world mostly. Like the equations that I teach you guys to do, you need to know how to do them, but like if you become a statistician or a research and developer, a lot of the stuff is going to be calculated by the click of a button, unfortunately. So, I mean, maybe not unfortunately. That's a good thing, I guess. All right, so this is the formula that they have for calculating adjusted R squared, and the thing that the adjusted R squared is based off of is the number of predictor variables that we have. So this is going to change, that K value is going to change our, it's going to make our adjusted equation different, okay? So that tells us that, all right? You go through and do example 2 really quick on the computer, okay? So if you get off of here and you click exit out of this, whew, my computer's running really slow. Go to example 2. We want to use, oh shoot, we gotta go back even, to foot and height data. Can you guys go backwards? And go back to the main screen where it's not body data, it's foot and height, which is right below body data. Can you guys get into that? Yes or no? Yes, okay. Go to foot and height data. It's going to pull up your next set of stuff. Not as many categories and probably not as many people that we have surveyed, but they want you to do age, foot length, shoe print length, shoe size, and height for each of the 40 different subjects, okay? You don't need to do all of them. Why is this not refreshing? Can you guys see it refreshed on me or no? Am I frozen? I'm frozen. I'm frozen. We might just have to wait till tomorrow to do example 2. Can we do that?
Yeah.
Oh, shucks. Okay, but you do have to do some problems for homework.
We can only do number 1.
Oh, you can only do number 1, body data?
The other one, you have to change the male or female.
Okay, yes, let's do that. Okay, so there you go. Do number 1. Number 1, you can't see this. Move a recording. I don't know why it's doing that. So go back to your body data. They want you to use body data for this homework. But number 1 does have A and a B. Okay, so there you go. Find the multiple regression. For age is your Y based on pulse, systolic, and diastolic. Do that. Okay, there you go. There's your number 1. All right, tomorrow we'll talk about dummy variable. It went back now, evidently. Okay, all right, so just get that one done for tomorrow. There you go.